Okay, we're moving on to equations now. So we need a new kind of mat to help us with equations. But first we kind of need to talk about equations. So an equation is like a balance scale. The two sides of an equation must equal the same number. If they do, then the two sides will be in balance. With algebra tiles, we use a sentence mat to model equations. So I'm going to show you what that sentence mat looks like really quickly. So this is a sentence mat. You're going to put tiles on both sides, and as long as they're equal to each other, the scales stay in balance. So modeling equations, so today we're going to practice modeling equations with algebra tiles on a sentence mat. We're also going to model the same equation in a different way by adding zero pairs. So that actually won't be new. It's just a reminder that that's a way that you can represent the same thing without really changing the value. We're also going to model the same equation in a different way by adding or taking away tiles on both sides of the sentence mat. Adding or taking away tiles on both sides of the sentence mat. And last thing we're going to practice is writing the new model as an algebraic equation. So we're starting this, we're going to say that we know that x equals -3. Okay, so if we know that x equals -3, we're going to put an x tile on one side of the sentence mat, and then we're going to put 3 red integer tiles on the other side. So let's actually draw that. Let's show you what that looks like. Here's yours. So we just say x. There's my x tile, right? On one side equals -3. Here are my 3 integer -3 tiles. So on the other side. So that's pretty simple. So you take the equation, you put the tiles from one side, put the tiles on the other. Okay, so you can draw that right here. X equals -3. And we shade on our drawings to show that, right? Okay, so now we're going to talk about representing the same equation, an equation with the same solution in different ways. So we already know that adding or taking away a zero pair will not change the value of an expression. So adding zero pairs, taking away, it doesn't change the value of an expression. Okay, this still holds true on a sentence mat. We can add zero pairs to either side of the sentence mat, and the value of x does not change. So here we have an equation that we already talked about, right? So here's some examples. We already have this equation, x equals -3, right? Well, I can add a zero pair to that. And I didn't change anything. I can add a zero pair to either side, right? I could add a zero pair. I could put 2 over here and 1 over here. Okay, and I haven't changed the value of x. So this is just a reminder that there are ways to change the way something looks without changing the value. And adding or taking away zero pairs is one way to do that. The value of x is still -3. We didn't change the balance scales. So you never want to change the balance scales. You don't want to tip it. But because -1 and +1 are 0, you're not going to tip the scales because you're just adding 0. And adding 0 won't tip a scale at all. It's like adding nothing. So the examples, let's draw this. The first example, we had an x and the -3 over here. And then we added a 0 pair. And adding that 0 pair is not going to make the balance scales tip because you're just adding 0. Right? It's like these two balance each other out. Okay? The second example we have these 3. And we added 2 0 pairs over here. And again, neither of these are going to make it tip. And then we went ahead and added 1 over here. And again, these two keep each other in balance as it is. So nothing's going to tip because it's basically like we added nothing to both sides. Now, we want to talk about writing this algebraically. This over here is like writing x equals, and we've got -3, but then we added a 0 pair. And you can write 0 pairs out like +1 plus a -1, or you could write it out as x equals -3 plus 0. Either way. But you see how we didn't really change the value of x, because either way, this still means x equals -3. And over here, I prefer writing it this way. So I'm going to say over here algebraically, this just models x plus 0 equals -3 plus 0 plus 0, right? Plus 2 zeros. And again, we didn't change anything because we were just adding 0. 0 doesn't change anything when we add. Okay? So on the back. But now that we have a balanced scale, there's another way to change the algebraic sentence of x equals -3. So you already knew adding 0 pairs wouldn't change things. But there's another way where we don't change the value. Okay? So in this particular way, so long
Timothy McNeil, your ride is in the front. Timothy McNeil, your ride is in the front.
So long as we keep the scales balanced, so long as we keep the scales balanced, the value of x does not change. So we can add a tile to one side or take away a tile from one side. Okay, so we can add a tile to one side as long as we add it to the other side. Or we can take away a tile from one side so long as we take away from the other. So here's some examples. Okay, again, we start with x equals -3, right? But now we could add a -1 to both sides, and it's still in balance. Because if I add something to this side, yeah, it might make it tip one way, but then if I add it to the other side, it'll keep in balance. And so this equation has the same value. Or we could add an x squared tile to one side. Now this would make the scale start to tip, but then if we add an x squared to this side, then it will be in balance. So you can keep doing this. You can keep adding tiles or taking away tiles. Here I could take away these two tiles. So I could take away this tile and I could take away that tile. As long as whatever I do to one side, I'm doing to the other, it's going to stay in balance. Okay, so let's write down those 3, right? So in the first example, we had, on all of these, we started with x, right? We started with x equals -3. But in this one, we added another -1 tile, right? And in this one, we added a -x squared tile. And we still had that -1 right there, right? Well, in this way, we kept the x squared tile, but we took away those, right? So we took those two away, and that's what this one looked like. So now that we modeled these, we'll write the algebraic equation. Right here, this is x plus -1 on this side equals -4 on this side. Right here, this is x squared, negative x squared, plus positive x plus -1, and on this side that equals negative x squared plus -4. So we're just writing down what's on each side, right? What's on this side, this time, this one is negative x squared plus x equals negative x squared plus -3. So you're just writing down what you see on each side, okay? The point being you can add or take away as long as you do it to both sides. So on your practice worksheet, you're going to be asked to model an equation, change it in specific ways, on the sentence mat, and then write the new equation algebraically. Okay, the two equations are going to have the same solution but look different. So notice all of these equations up here have the solution of x equals -3. All of them. If I plug -3 in for x, they all will work. But they look different, right? So that's what we're practicing here, is things that have the same solution but look different. So here's an example problem. We want to model negative x plus 3 equals -2 plus x. So we're going to put a negative x on this side plus 3 positive tiles, 3 positive integer tiles. We're going to put a -2 integer tiles on this side plus a positive x. Now, this instruction says add a 0 pair of x shapes to the left side. Okay, so we have the same thing that we started with, but now it wants us to add a 0 pair of x shapes. And that's something we didn't really practice, but this is a 0 pair, and to the left side, this is a 0 pair of x shapes, right? Okay, now on this over here, we're going to draw the same thing that we have. So this is each a step. So I'm drawing this over here. And then 1, 2, 3. And I've got still two negative integer tiles on this side and then 1. But this one says take an x away from both sides. Take a positive x away from both sides. So cross that off, right? So cross that off. And now what am I left with? Write the new equation algebraically. So do you see how I started with this equation and I followed the rules? I'm allowed to add a 0 pair. And then I followed more rules. I'm allowed to, if I take something away from one side, I can take it away from the other. And now the new equation algebraically. I've got a positive 3 on this side, I've got a negative 2x on this side, and I've got a negative 2 on that side, right? So this is my new algebraic equation. These two equations have the same solution. They just look different. But you can see how we modeled them. We followed mathematical rules to transform them without changing the value.